Hi, I'm Luke at Cloud Consultant and welcome to part 2 of Compute Networking, which is unit 4 of our AZ-900 Azure Fundamentals Cram. So in part 1 of this we talked about the different compute options. We're now going to look at networking, which is VNets, including VPNs and express route, and then DNS. So first things first, what's a virtual network? It is what it sounds like. It is a virtualized networking. So you have a bunch of machines connected to each other by cables. Well, in the cloud, this is all virtualized, so they're not just one machine connected by one cable. It's more complicated than that, but logically, it's just like that. It's like having a bunch of virtual machines that have cables to each other, right? Now, why do we use them? For isolation and segmentation. So we have our original VNet that we'll create, and then we have subnets within that, so sub-networks. But the one important thing to realise here is that private IP ranges can be used for VNets and subnets. So a public IP is the IP address that makes your computer or your service publicly available and accessible via the internet. If you have private IPs, then you don't need a globally unique IP because you don't need the internet to come and get you. So, communication. How do you connect with and to and between virtual networks? So, first is the internet. This here is a public IP icon. Oh, there's the cat. So, you can access a virtual network via the internet if you use a public IP. Next up, Azure services. So, some Azure services will automatically route, for example, virtual machines in Kubernetes. Other ones you have to use service endpoints, such as like SQL databases and storage accounts. Now, if you want to communicate on-prem, you get two options, ExpressRoute and VPN. ExpressRoute is essentially a direct cable between your premises, your on-prem, and Azure. VPN, on the other hand, goes over the internet, so you can think of the security considerations there, and it can be either a site-to-site VPN or a point-to-site VPN. A site-to-site VPN is from the actual site itself, so say from your data center, then uses a tunnel straight to Azure, right? Whereas a point-to-site would use a point, not a site, so a point would be like a laptop, and for that, there's other ways that we can tunnel it through. You don't need to know the intricacies for AZ-900. So within ExpressRoute here, we have a couple of things that you can have a quick read. I'll briefly say them out loud. Security considerations, it's never over the internet. The features and benefits, connectivity to Microsoft Cloud Services, global connectivity, dynamic routing via BGP, which is a protocol, and it's built-in redundancy at every peering location. So how do we connect to Azure via ExpressRoute? That's where we have these connectivity models. Number one, co-location at a cloud exchange. Cloud exchange is an exchange where cloud traffic is routed through. If you can co-locate your physical servers at this exchange, you can then request a virtual cross-connect to get that routed towards Azure. Now that way you don't have to go over the internet. Next is point-to-point Ethernet, so just a cable between you and Azure. Then any-to-any networks, so if you already have a wide area network, which is a WAN, W-A-N here, you can integrate that into Azure, right? Finally, directly from ExpressRoute sites. So this is kind of like point-to-point, except point-to-point is usually provided by some third party, whereas directly from ExpressRoute is exactly that. It is directly from Azure. Now, next, within VPN, you recall we had this site-to-site and point-to-site. Now, what is a VPN? It uses an encrypted tunnel within another network. Right, you might kicked it. And so to connect to your virtual network via a VPN, you require a VPN gateway. Now, because that's a way to connect to your virtual network, you can only have one per VNet, and it goes in its own subnet. Now, the VPN types that we have are policy-based and route-based. You can read more about it here, but essentially, policy-based, you can imagine that they're checking every single person that comes through, so every single packet, which is the way that internet is routed and passed across the internet is through packets, which are like small chunks, and each of these chunks will have a specific where it's coming from, where it's going to, what protocol it's using, essentially, and then the information. So for each of these, it statically looks at the specific packet and is like, right, where is this going to go? Whereas route-based, it's much more abstracted, and because of that, It's more resilient to topology changes such as creation of new subnets, because if things are changed, it doesn't have to re-look at every single packet and update all these rules. It kind of dynamically moves with it, right? So instead of manually setting policies for each IP, the system uses normal routing to send traffic through the relevant tunnels, and then encryption happens automatically within these tunnels. So instead of encrypting every single guy that comes in, it's like, right, you go into that tunnel, you go into that tunnel. Now, high availability scenarios, so this is where you want to have like a failover VPN gateway. So you don't want just one in case something goes wrong. You want this high availability. So we have active standby, which is the default. During this failover, it will be a few seconds if it's planned, or if it's not planned, it's supposed to be less than 90 seconds, but there is no agreed SLA for that. Active standby means you deploy two, one's active, one's just on standby waiting in case there's a failure. Now, you also get active where both of these guys are active, right? And so this is leveraging this BGP protocol that we previously talked about. And because we have two and they're active, there's an IP address for each of them, with separate tunnels from on-site to each, so it's like two access points. They can also be used as an express route failover, so if your direct connection doesn't work, you can then use the VPN. We can also have zone redundant gateways, which are automatic for express routes and VPN gateways in regions that support availability zones, so multiple. And these gateways require different gateway stock keeping units, SKUs, and use standard public IP addresses instead of basic public IP addresses. Now, this is one to recall for the exam between standard and basic. You think of basic as the one provided by the internet, right? So you have a specific public IP and it has no extra features. Standard is where it has some of the extra features provided by Azure. Now, next up, if we scroll up here, we have VNets. So VNets to VNets. Now, this is called peering, and it goes over the Microsoft backbone, so over the Azure backbone, meaning it's not across the internet. And now, user-defined routes allow you to control routing between these subnets and VNets, so between subnets within different VNets to talk to one another. So, within virtual networking, what happens with the network traffic? Now, it can be filtered and it can be routed. So, filtering, normally, is between either an NSG, which is a network security group, or a network virtual appliance. Now, NSG allows or blocks traffic based on inbound and outbound security rules, which include your IP, your port and protocol. So basically you say allow from this inbound specific location this, or block from this outbound, so don't let this specific message leave the virtual network. So if it was something like you don't want anything to do with the internet, you want your VNet to be fully private, right? You would block traffic out of the network that goes to the internet and in. Now, network virtual appliances, instead, these are actually just specialized virtual machines. For example, you get firewall or WAN optimization. Now, routing, you get that via a routing table, so a route table where you go, if it's coming from here and it's going here, this is the direction it needs to go in. And this is enabled using the Border Gateway Protocol. So this works with Azure VPN gateways, Azure Route Server, or Azure Express Route to propagate on-prem BGP routes to Azure Virtual Networks. Now, DNS, Domain Name System. So this is essentially your phone book for the internet. If you have a name, it then gives you the IP address. This is a hosting service for DNS domains provided by Azure. The benefits: reliability and performance, so anycast networking, so the closest available DNS server answers each query. Security is based on Azure Resource Manager, so it uses RBAC, activity logs, resource locking, etc. Ease of use, because it's just directly in the portal. Customizable VNets with private domains. And finally, alias records, which is like if you had google.com, an alias would be test.google.com, dev.google.com. Now, these alias records, these are normally used for resources such as traffic manager profiles or CDN endpoint, which are content delivery networks. So instead of being like the main source, you can have sub-sources that you can access instead. So if you were like on Netflix, instead of going to Netflix.com, the actual big Netflix.com, you can go to a CDN which holds some of Netflix's data, especially stuff that's been being used right now. So for example, when the TV show You comes out, right, they will have all of the episodes of You in this CDN which is in the UK, because then instead of having to go all the way to America to get the You episodes, you can just stream it from the UK CDN, and that'll maybe be called uk.netflix.com. So if you have an alias for a service instance, for example CDN, right, if you have a CDN service instance, this service instance is associated with an IP address, and because the alias points to the service instance, if the underlying IP address changes, then it's all good and it doesn't have to worry about it. Now that is us for compute and networking. Come back next time where we will cover Unit 5, storage.